Uh, Good evening, dear students. So, I am Siddegowda, lecturer in chemistry, Seshadripuram PU College, Mysore. Today, I am going to discuss about the Kcet Chemistry 2023 question paper. So, in this question paper, about out of 60 questions, 20 questions are out of syllabus questions. Means deleted from deleted chapters. So, remaining questions, I am going to discuss about that. So, let us start. Question number 1. First question is question number 1. Compounds P and R in the following reactions. The reactions is given. So CH3CHO aldehyde reacts with the methyl magnesium bromide. It's a Grignard reagent. Followed by hydrolysis gives compound P. Then compound P is treated with concentrated sulfuric acid. Treated with concentrated sulfuric acid gives compound Q. Then compound Q is treated with diborane and followed by oxidation with hydrogen peroxide gives compound R. So in the sequence of the reaction is, in this question, first reactant, main reactant is aldehyde, acetaldehyde. Then acetaldehyde is retreated with methyl magnesium bromide. It's a Grignard reagent to undergo nucleophilic substitution reactions. So methyl magnesium bromide. So acetaldehyde reacts with the methyl magnesium bromide. It's a Grignard reagent. Undergo nucleophilic addition reaction. So nucleophilic addition reactions. Here, the partially positive charge, negative, partially positive and negative charge, carbon atom carrying the functional group. So here, it's NH is Grignard reagent to methyl group is partially negative in nature, magnesium is partially positive in nature. So this CH3 group attached to the carbonyl carbon and MgBr attached to the oxygen atom of the carbonyl carbon atom. So then the gives the addition product. So the addition product is CH3 COMgBr, then CH, then CH3. This is the addition product. Then followed by hydrolysis with H3O plus, it gives the compound. Compound is CH3 COH CH3. So the compound P is propane 12. The compound P is propane 12. Then propane 12 subjected to treated with concentrated sulfuric acid. It undergo dehydration reaction to give the product CH3 CH double bond CH2. So propene is the next product. Here the product Q is propene. Then propene Q is treated with diborane. Diborane is B2H6. Actually, this reactions is hydroboration oxidation reactions will take place when treated with propene treated with borane. So this trialkyl bromide is the addition product. The trialkyl borane. Then this undergo hydrolysis with hydrogen peroxide, oxidation with hydrogen peroxide. It gives, the compound gives CH3, CH2, CH2OH. So here the question is the relationship between the P and Q, P and R, the product P and R. So what type of relation is this one? Is here, so metamers, identical, position isomers and function isomers. So compare propane 2-ol and propane 1-ol. So final product R is propane 1-ol. So these two are related with the position isomers, because why they are called position isomers? Here the compounds having the same molecular formula, but the same structural formula, but differ in the position of the functional group. In propane 1-ol, position of the alcohol functional group is carbon atom number 1. In propane 2-ol, position of the functional group alcohol is carbon atom number 2. Therefore, the correct answer is C. For question number 1, The correct answer is position isomers. Next, let us move on to the next question. So next question is, aniline does not undergo. Aniline does not undergo what type of reaction? So here the option A is given Friedel-Crafts reaction, option B is given bromination reaction, option C is nitration reaction, option D sulfonation reaction. Let us discuss one by one. So aniline, the question is what type of reactions aniline does not undergo what type of reactions. Here let us discuss with Friedel-Crafts reactions. So aniline reacts with the Friedel-Crafts reactions. Friedel-Crafts reactions reagent is aluminum chloride. So actually, what you mean by Friedel-Crafts reaction means nothing but replacement of alkyl group to the aromatic ring. So when aromatic hydrocarbons are treated with alkyl halide, for example, alkyl chloride, in presence of anhydrous aluminum chloride catalyst. Here, aluminum chloride acts as a catalyst. Then the product is toluene or methyl benzene is formed. So methyl group is attached to the aromatic group in the Friedel-Crafts reactions. Let us check with the aniline. So when aniline is treated with aluminum chloride, methyl chloride, CH3Cl, in presence of aluminum chloride catalyst. So what happens here is aluminum chloride is a Lewis acid, electron deficient species. It is a Lewis acid. So here ammonia, aniline, due to the presence of lone pair electrons on nitrogen atom, aniline acts as a base. Therefore, here base reacts with acid to form a salt. To form salt, anilinium aluminum chloride salt, AlCl3 minus. So form salt. Because of this reason, so aniline does not undergo Friedel-Crafts reactions. Actual Friedel-Crafts reaction is replacement, addition of alkyl group to the aromatic ring. Here addition for aniline, addition of alkyl group through Friedel-Crafts reaction is not possible because of why? Because aluminum chloride directly reacts with aniline to form a salt. So actually first step in the Friedel-Crafts reaction is production of carbocation, methyl carbocation. So when okay, therefore aniline does not undergo Friedel-Crafts reaction. The main reason is aniline acts as a base, reacts with Lewis acid, aluminum chloride to form salt. So correct option for question number 2 is Friedel-Crafts reaction. Option A is correct. Next, let us move on to the next question. Question number 3. Heating of phenyl methyl ether with hydrogen iodide produces aromatic compound A, which on treatment with concentrated HNO3 gives B. A and B are respectively. The question is, options are, so option A is iodobenzene, 1-iodo, 4-nitrobenzene. Option B is phenol picric acid. Option H5OCH3. This is phenyl methyl ether. When treated with hydrogen iodide, phenyl methyl ether is treated with hydrogen iodide. The product formed. So there are two types of products are formed here. So one of the product is an aromatic compound A. Aromatic compound A is here hydrogen is attached to the oxygen atom, iodide ion attached to the methyl group. So then the product is phenol C6H5OH. Aromatic compound A here is phenol. Another product is methyl iodide. Then phenol is treated with concentrated HNO3. Phenol is treated with concentrated HNO3. Concentrated HNO3. It takes place, nitration takes place both ortho and para positions when treated with concentrated nitric acid. So nitro group is attached to both ortho group and also para group. The product is 2,4,6 trinitrophenol. The product is 2,4,6 trinitrophenol. So another name of 2,4,6 trinitrophenol is called picric acid. So picric acid. Therefore, the option, the compound A is phenol, the compound B is picric acid. The correct option is B, phenol and picric acid. Okay. So next, let us move on to the question number 4. So question number 4 here, the sequence of reactions are given. So you have to find out the product A, B, and Y. So question is why major product? Why is the major product? Why in the above reactions? So here first main reactant is here phenol. Then phenol is treated with the sodium hydroxide. So to form sodium phenoxide, then it is treated with the carbon dioxide, then followed by treated with acid. So actually it is a coal-based reaction. Coal-based reaction. So it gives phenyl salicylic acid. So 2-hydroxy benzoic acid is formed. When it is undergo phenoxide undergo coal-based reaction to form 2-hydroxy benzoic acid. So another name of 2-hydroxy benzoic acid is salicylic acid is formed first. So first product B is salicylic acid. Product A is sodium phenoxide. After that, when salicylic acid is treated with acetic anhydride and followed by in presence of concentrated acid H2SO4, actually this is esterification reaction. Esterification reaction. So what happens here is when salicylic acid is treated with acetic anhydride. So acetylation reaction takes place. So addition of CH3CO group, okay, to the alcoholic functional group. So when treated with acetic anhydride, CH3CO twice O, and followed in presence of concentrated sulfuric acid. So acetylation reaction takes place. The product is acetyl salicylic acid. Product is acetyl salicylic acid. This is what we called as acetyl salicylic acid. So another name of acetyl salicylic acid is aspirin. It's an important drug used as an analgesic. So this is the major product. Why is acetyl salicylic acid? So another name of acetyl salicylic acid is aspirin. So the correct option is the Y in the above reaction is aspirin. The correct option is D. Question number 4. The correct answer is aspirin. Now let us move on to the next question. Question number 5. A better reagent to oxidize primary alcohols into aldehydes. Here, primary alcohols into aldehyde. Usually, what happens in the oxidation of alcohol is when treated with a strong oxidizing agent like acidified potassium dichromate, potassium permanganate. So usually primary alcohol first oxidized to aldehyde. corresponding aldehyde. Then aldehyde further oxidized to acid, carboxylic acid. This is the reaction is going on in the oxidation of alcohols, primary alcohols. So when using strong oxidizing agent, subsequently, alcohols oxidized by the final product is carboxylic acid. So when treated with secondary alcohol treated with strong oxidizing agent, like undergo oxidation, to the product is ketone. Then so under strong conditions, again further ketone oxidized to carboxylic acid. This is the how reaction is going on, oxidation reaction going on in alcohols. So here the question is the better reagent to oxidize primary alcohols into aldehydes. The better reagent means want to restrict the reaction, control the reaction at the aldehyde stage only. So the better reagent used to oxidize primary alcohols to aldehyde stage only, the better reagent is PCC. So PCC is a pyridinium chlorochromate. PCC abbreviation is a chromium compound, complex of chromium trioxide with pyridine and HCl. So pyridinium chlorochromate, the PCC, when treated with then primary alcohol treated with PCC, pyridinium chlorochromate reagent. So primary alcohol oxidized to aldehyde, further oxidation will not take place. PCC restrict the oxidation of primary alcohol to aldehyde stage only. So this is the better reagent. PCC is the better reagent to oxidize primary alcohols into aldehyde. The correct option is C. Question number 5. The correct answer is C, PCC. Next, let us move on to the next question. Question number 6. In the reaction C6H5Cn in the presence of stannous chloride and HCl and followed by hydrolysis, the compound X is formed. And the compound X is treated with the concentrated KOH to form two compounds Y and Z. So formation of Y and Z are known by. So here the reaction name is given in the options, all the 4 options. So what type of is reaction is this one? So let us check one by one. First, when nitriles C6H5Cn is treated with the stannous chloride SnCl2 in presence of HCl. Okay, so to form undergo nitriles are reduced to in the presence of stannous chloride and HCl in the presence of HCl. So the nitriles are reduced to imine product. So let us forget about the phenyl group. Let us take CN first. So here let us see the phenyl group are considered as R. Then R CH double bond NH. First, the product imine is formed when treated with stannous chloride and HCl. So nitriles are reduced, undergo reduction, reduced to imine, then followed by hydrolysis. So imine in presence of water, followed by hydrolysis, undergo gives corresponding aldehyde. This reaction is known as Stephen reaction. So this reaction is known as Stephen reaction. We studied in the chapter aldehydes, ketones, and carboxylic acid. So under the concept for the preparation of aldehydes and ketones. So under that we studied about this reactions, Stephen reaction. Then the aldehyde treated with the concentrated potassium hydroxide or concentrated alkali. So undergo Cannizzaro reaction when treated with concentrated KOH, undergo What type of reactions undergo Cannizzaro reaction? So in Cannizzaro reactions, what happens is two molecules of the aldehydes which do not contain alpha hydrogen atom undergo oxidation and reduction reactions to form a compound alcohol and salt, sodium benzoate salt. For example, let us compound which do not contain alpha hydrogen atom is C6H5CHO. When treated with concentrated HL, so two molecules of benzoaldehyde undergo self-oxidation and reduction. So one molecule of benzoaldehyde is reduced to benzyl alcohol C6H5CH2OH. Another molecule of aldehyde oxidized to sodium benzoate C6H5COOH. So this reactions known as Cannizzaro reactions. Therefore, option B is the correct answer. Question number 6, option B is the correct one. So first one is this one is Stephen reaction. Then X2, Y and Z is the Cannizzaro reaction. Okay. So question number 6, correct option is B, Stephen reaction and Cannizzaro reactions. Now let us move on to the question number 7. So in this question, so sequence of reactions are given, intermediate products and final products are also given. So reagents are not given in this. So I want to identify the intermediate reagent PQR. So first reactant is aniline. This one is aniline. So second one is diazonium, benzene diazonium. Second one is benzene. Second one is benzene diazonium. Diazonium chloride. Then third one is diazonium fluoroborate. So diazonium fluoroborate. The final product is nitrobenzene. Final product is nitrobenzene. So here first let us check. Let us find out what is the reagent P. So here, so first aniline gives benzene diazonium chloride. Actually, this is diazonium reaction. Diazotization reactions. In diazotization reaction, the reagent used is nitrous acid. Diazotization reactions. Here P is HNO2. So let us check which options HNO2 is there. So HNO2 is not in the following all the options. So instead of HNO2, so aniline is treated with NaNO2, sodium nitrate with dilute HCl. So when treated with NaNO2 and dilute HCl, in the reaction itself, HNO2 is produced. So HNO2 is produced. The product is benzene diazonium chloride. Therefore, option P is NaNO2 and dilute HCl. Option A as NaNO2 dilute HCl. Option C as NaNO2 dilute HCl. And option D also has NaNO2 dilute HCl. So option B is not the correct answer because here is given NaNO3 and dilute HCl. So actual reagent is sodium nitrite, not nitrate. So option B is not possible. Now let us check the reagent Q. When benzene diazonium chloride treated with the Q, the product formed is diazonium fluoroborate. The product formed is diazonium fluoroborate. Diazonium fluoroborate. So in these reactions, when diazonium chloride is treated with hydrofluoroboric acid. So let us say fluoroboric acid is HbF4. So let us check the option one by one. So option A, boron trifluoride is given. So option A is not possible, not the correct answer. Next option B, here F2 is given. Therefore option B already ruled out. Then option C is given, HbF4. Okay, HbF4 is given, fluoroboric acid. So the Q is HbF4 and the P is NaNO2 and dilute HCl. Next, let us check R, the given reactions. When diazonium fluoroborate is treated with R, it gives nitrobenzene, means replacement of diazo group by nitro group. So what is the reagent used to replace diazo group by nitro group? The answer is when the diazonium fluoroborate is treated with the sodium nitrite NaNO2 and copper gives gives nitrobenzene. So when the diazonium fluoroborate compound is treated with sodium nitrate and copper, so diazo group replaced by nitro group, the final product is nitrobenzene. Therefore, correct option is C in the given. So NaNO2 Cu plus Cu. So correct answer for this question number 7 is option C. In option D, NaNO3 is given. This is not possible. So correct option is C. So P is NaNO2 plus dilute HCl, Q is HbF4 and R is Cu plus NaNO2. Next, let us go to the question number 8. Question number 8. Thyroxine produced in the thyroid gland is an iodinated derivative of. So it is a direct question. It's an iodinated derivative of tyrosine. Thyroxine produced in the thyroid gland is iodinated derivative of tyrosine. Actually, it's a amino acid derivative. Tyrosine is a thyroxine is an amino acid derivative in which the amino acid tyrosine is bonded with iodine. So covalently bonded with iodine in different positions. 3 or 4 positions. So therefore, the correct option is A, tyrosine. Actually, another name of tyrosine T3, T4, T3, abbreviated as T3, tyrosine. So correct option is A. Next, let us move on to the question number 9. Let us move on to the question number 9. Sucrose is dextrorotatory, but after hydrolysis, the mixture shows levorotation. This is because option A is racemic mixture is formed. Option B is levorotation of fructose is more than dextrorotation of glucose. Option C is levorotation of glucose is more than dextrorotation of fructose. Option D is sucrose is a non-reducing sugar. Here, actually, the correct sucrose after undergo hydrolysis. Sucrose undergo hydrolysis to produce glucose and fructose. To produce glucose and fructose. So produce what type of glucose and fructose? So here produce D plus glucose, D minus fructose. So here D plus stands for dextrorotatory, D minus stands for levorotatory. So actual sucrose is dextrorotatory. So it is a D plus sucrose. Dextrorotatory means rotate the plane polarized light towards the right direction. So up to about plus 66.5 degree sucrose. So sucrose is dextrorotatory. The compound sucrose is dextrorotatory. After hydrolysis, the mixture is levorotation. So levorotatory. The mixture is levorotatory. This is because glucose is dextrorotatory, but the rotation is right to rotate the plane polar light towards the right direction about 52.5 degree, but fructose rotate the plane polarized light towards left about minus 92.4 degree. So in this what happens, the mixture is, because of this mixture is levorotatory. So levorotation of fructose is more than the dextrorotation of glucose. Therefore, the mixture is levorotation. The correct answer is B. Levorotation of fructose is more than the dextrorotation of glucose. The correct option is B. Now, let us go to the next question. Question number 10. The correct order of match between the column X and the column Y is. So here, column X, first one, vitamin A. Vitamin A deficiencies are given in the column Y. So column X is given, vitamins are given in the column X. Column Y is their deficiency, vitamin deficiencies are given in the column Y. So the correct option is here vitamin A. Vitamin A is deficiency of vitamin A is night blindness. Therefore, option for 1, 3. So for 1, vitamin A is 3, night blindness. Next, vitamin D is 4, osteomalacia. So bone disorder, usually found in the adults. That is second one is, fourth one is correct, column Y. Then vitamin E. Vitamin E is a muscular weakness. So third one is first one is correct. So the remaining one is the fourth, vitamin K. Vitamin K for fourth one. So increased blood clotting type. So that is second one is correct. Therefore, correct answer is B. So it's also direct question. Next, let us go to the question number 11. Lattice enthalpy of NaCl is plus 788 kilojoule per mole, and standard enthalpy of hydration is also given, that is minus 784 kilojoule per mole. And then enthalpy of solution of NaCl is, actually what happens in the enthalpy of solution is, here NaCl solid compound, so when dissolved in water, to convert it into, so as ions are dissociated to form aqueous sodium ion and aqueous chloride ion. Actually, theoretically, this reaction takes place in 2 steps. So this mean reaction is nothing but the enthalpy change takes place during this reaction is called enthalpy of solution. So what is mean enthalpy of solution? When 1 mole of enthalpy change, when 1 mole of ionic compound dissociated into its aqueous ions in excess of water is called excess of solvent, suitable solvent is called enthalpy of solution. So then actually this reaction, this process takes place in 2 steps. Step number 1, solid ammonia sodium chloride, solid ionic compound, dissociated into its gaseous ion first. Dissociated into gaseous ion. This is the first step. This is what we called lattice enthalpy. The enthalpy change during this process is called lattice enthalpy. What do you mean by lattice enthalpy? So, enthalpy change when 1 mole of ionic compound dissociated into its gaseous ion, or also explain defined like this. So, enthalpy, lattice enthalpy means enthalpy change when 1 mole of ionic compound formed from its gaseous ions. So, this is the first step. So, second step, when ionic gaseous ions formed, then when treated with the water in presence of solvent, they are surrounded by water molecules. For example, NaCl, positively charged ion, surrounded by water molecule. Water structure of water is a bend-like structure. Here, partially negative charge is oxygen, partially positive charge is hydrogen. So, sodium ion, so you can represent the water molecule like this. Sodium ion surrounded by water molecule like this. Similarly, chloride ion surrounded by water molecule like this. This is what we called as hydration, addition of water molecules to ions. So the enthalpy change. So during this hydration process is called enthalpy of hydration, standard enthalpy of hydration. What is given in the question is lattice enthalpy is given and also hydration enthalpy is given, and want to find out the enthalpy of the solution. So here you have to apply to find the enthalpy of solution. So you have to apply SS law. What is SS law? Whether reaction takes place in one step or in a number of steps, enthalpy change remains same. Enthalpy change remains same. Or enthalpy of a cyclic process, enthalpy change during a cyclic process is equal to 0 according to SS law. So apply SS law for this cycle first. So this is single step. This is single step process. So solution, enthalpy of solution. So this is a two-step process. These two are two-step process. So according to SS law, enthalpy of solution is equal to the sum of the lattice enthalpy and hydration enthalpy. So lattice enthalpy is given, that is plus 788 kilojoule per mole, and hydration enthalpy is also given, that is 784 kilojoule per mole. The answer is the enthalpy of solution is 4 kilojoule per mole plus 4 kilojoule per mole. The correct answer is D, plus 4 kilojoule per mole. This is how you can calculate enthalpy of solution using applying SS law. Now let us go to the next question. Question number 12. At 500 Kelvin, for a reversible reaction, A2 plus B2 that give rise to 2AB in a closed container. So equilibrium constant is given, that is Kc is equal to 2 into 10 to the power minus 5. In the presence of catalyst, the equilibrium is attaining 10 times faster. The equilibrium constant Kc in the presence of catalyst at the same temperature is here. The important word is at the same temperature. So at 500 Kelvin, reversible reaction is given. Reversible reaction takes place in a closed container. So equilibrium constant is given, that is 2 into 10 to the power minus 5. In the presence of catalyst, the equilibrium is attaining 10 times faster. Here, so equilibrium constant, okay, Kc, in the presence of catalyst at the same temperature. So by using the catalyst, so what happens? Equilibrium constant is given, that is 2 into 10 to the power minus 5. So equilibrium constant after using in the presence of catalyst, equilibrium attaining 10 times faster. It means so rate constant of forward reaction divided by rate constant of backward reaction. By using catalyst, rate constant both reactions, both forward and backward reaction takes place at the same rate. So 10 times 10 of Kf divided by 10 of Kb. So remains the same. So equilibrium constant do not change by using the catalyst. Equilibrium constant only change. Equilibrium constant can alter by using the temperature. So only temperature can alter the equilibrium constant. Therefore, the correct answer is equilibrium constant value does not change with by changing by using the catalyst. So our correct answer is B, 2 into 10 to the power minus 5 only. Kc, equilibrium constant, depends on temperature, not depend upon the catalyst what we used. This catalyst is just increase the rate of reactions. Catalyst, when we use the catalyst, rate of reactions increases, but the equilibrium constant remains same. So the correct answer is option B, 2 into 10 to the power minus 5 only. So next, let us go to the question number 13. A weak acid with pKa 5.9 and weak base with pKb 5.8 are mixed in equal proportions. pH of the resulting solution is. This is also a direct questions. The pH of the resulting mixture calculated by using the formula pH is equal to 7 plus half into pKa minus pKb. Here pKa value is given, pKb value is given. So calculate pH. 7 plus half into pKa value is 5.9 minus pKb value is given, that is 5.8. The answer is 7.05. Final answer is 7.05. The pH of the resulting mixture, pH of the resulting solution is 7.05. The correct option is B. The right question. Question number 13. Correct option is B, 7.05. Next, question number 40. Temperature of 25 degrees Celsius in Fahrenheit and Kelvin scale respectively are. So temperature, Fahrenheit scale is given, Kelvin scale and degree Celsius also given. So degree Celsius to Kelvin relationship is, degree Celsius to Kelvin is, Kelvin is equal to 273.15 plus degree Celsius. This is the relationship between degree Celsius and Kelvin relationship is Kelvin is equal to 273.15 plus degree Celsius. So then relationship between degree Fahrenheit and degree Celsius is Fahrenheit, degree Fahrenheit is equal to 9 by 5 into degree Celsius plus 32. So let us calculate first Kelvin. Here 273.15 plus 25 degrees Celsius. That is degree Kelvin is 298.15 Kelvin. Next, let us calculate degree Fahrenheit. So 9 by 5 into 25 degrees Celsius, 25 plus 32. 5 is the answer is 77 degree Fahrenheit. The correct option is degree Fahrenheit is 77 degree and degree Kelvin is 298.15 Kelvin. The correct option is C. Correct option is C. Question number 14. Next, let us go to the next question. Question number 15. Question number 15. The number of protons, neutrons, electrons in the ion 16, 32 sulfur ion respectively. Number of protons, neutrons, electrons in the ion. Here, so X, okay. Here atomic number is given, that is symbol is like this, Z, A. Here Z is atomic number, A is mass number. Mass number is equal to the sum of the protons plus neutron. So atomic number is equal to the number of protons or number of electrons. So here first calculate protons, neutrons and electrons. So mass number is given, that is atomic number is 16. It means this contains 16 proton, 16 electron. Or so here the given species is ion. To the unit of 2 unit of negative charge. It means 2 extra electrons added in the species. There's a total number of electrons present in the given ion is 18 electrons. So 18 electrons in the which option? So option A is number of electron is given 16. Option B, number of electron given 16. Option C also number of electrons given 16. But option D, number of electron is given 18. Therefore, correct option is D only. So here proton, for example, here mass number is 32. So it is the sum of the protons and sum of the neutrons. Sum of number of protons present in the species is 16. Calculate number of neutrons. Number of neutrons also 16. Therefore, so number of protons present in the species is 16. Number of neutrons present in the species is 16. So total number of electrons present in the species is 18 because of 2 unit of negative charge indicates 2 electrons added into this species. So next, the correct option is option D is correct. Next, let us go to the question number 16. Question number 16. The correct order of first ionization enthalpy of a given element is. The elements given in these are, this is option A. These are carbon is given, boron, beryllium, and lithium is given. So these are all belongs to first period of the periodic table. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So first second period. So belongs to second period. Ionization and first ionization enthalpy of the given element. The correct order is actually across the period ionization enthalpy increases with increasing atomic number because of effective nuclear charge increases. Effective nuclear charge increases. Therefore, ionization enthalpy also increases. So the correct option is a lithium ionization energy is less than beryllium. Ionization enthalpy is less than boron and it is less than carbon. But the actual sequence is lithium ionization enthalpy is less than boron, it is less than beryllium, then it is less than carbon. So here there is a change. Boron and beryllium because their electronic configurations. Boron atomic number of beryllium is 3. Electronic configuration is 1s2, 2s1. 2s2 beryllium electronic configuration, and boron electronic configuration atomic number is beryllium is 4, atomic number of boron is 5, electronic configuration of boron is 1s2, 2s2, 2p1. So compared to boron, beryllium has stable electronic configuration. So completely filled 2s orbitals. Therefore, beryllium has more first ionization enthalpy of beryllium is more than the boron, because it is in boron it is easy to remove the electron present in 2p orbital. Only one electron present in the 2p orbital. But in case of beryllium, two orbitals are completely filled. Stable electronic. Due to the stable electronic configuration of beryllium, ionization enthalpy of beryllium is more than the boron. Therefore, the correct sequence is lithium ionization enthalpy is less than boron, then beryllium, then carbon. The option C is correct. Correct option is C. Lithium less than boron, less than beryllium, and less than carbon. So reason behind this change of first ionization enthalpy of beryllium and boron because of their electronic configuration. Beryllium has stable electronic configuration. Next, let us go to the question number 70. Which of the following statement is incorrect? Here, which of the following statement is incorrect? Here, so before going to solve these questions, here bond length of O2 and bond length of O2 2 minus is given, and bond order also given. Bond order of O2 and bond order of O2 2 minus is given. First, let us calculate the bond order. So based on that, we can use it by using this relationship. Bond order is directly proportional to bond energy is directly proportional to stability. It is directly inversely proportional to bond length. By using this relationship, we can easily solve the questions, the above questions. Here, first let us calculate the bond order of O2 and O2 2 minus. So by using the electronic configuration, the molecular electronic configurations of O2 and O2 2 minus. First, let us write the molecular electronic configurations. For O2, we use this sequence, increasing order of molecular orbitals. Sigma 1s is less than sigma star 1s. It is less than sigma 2s. It is less than sigma star 2s, less than sigma 2pz, less than pi 2px is equal to pi 2py. Why these two are equal? Because these two are degenerate orbitals, equal energy orbital. Then it is less than pi star 2px, that is equal to pi star 2py, less than sigma star 2pz. First, let us calculate the bond order of O2. So for bond order of O2, so O2 contains 16 electrons. First, fill the 16 electron to the molecular electron configuration of 16 electrons. Here 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16. So calculate the bond order. Bond order formula, bond order is equal to half into Nb minus Ne. Nb means number of electrons present in bonding molecular orbitals. Ne means number of electrons present in anti-bonding molecular orbitals. Here, number of electrons present in bonding molecular orbitals are 2, 2, 4, 6, 8, 10. So number of electrons present in bonding molecular orbitals 10. Number of electrons present in anti-bonding molecular orbital is 2, 4, 5, and 6. So therefore bond order is 2. So bond order of oxygen is O2 is 2. Then bond order of O2 minus. O2 2 minus. O2 2 minus means number of electrons present in O2 2 minus. O2 is number of electrons present in O2 is 16 electrons. Number of electrons present in O2 2 minus ion is 18 electrons. So to calculate the bond order for O2 2 minus, just add 2 electrons here, anti-bonding molecular orbitals, pi star 2px and pi star 2py. Already 16 electrons are distributed. So 2 more electrons, so plus 1, plus 1. Totally, electrons present in bonding molecule remains same, 10. Electrons present in anti-bonding molecular orbital is 8. Therefore, bond order of O2 2 minus is 1. Bond order of O2 2 minus is 1. Now, let us check the answers one by one. Option A, bond length of O2 is less than bond length of O2 2 minus. Bond length is inversely proportional to bond order. So bond order of O2 2 minus is 1. Bond order of O2 is 2. Therefore, this is bond length of O2 is less than so bond length of O2 is less than bond length of O2. So incorrect. So which of the following statement is incorrect? This statement is correct statement because bond order of O2 is 2, bond order of O2 2 minus is 1. So the statement A is correct. Bond length of O2 is less than bond length of O2 2 minus. Next, let us go check the option B. So bond order of O2 is greater than bond order of O2 2 minus. That is also correct statement. Bond order of O2 is 2. Bond order of O2 2 minus is 1. So bond order of O2 is greater than bond order of O2 2 minus. And now let us take the that is also B is also not the correct answer. Next, let us check the option C. Bond length of O2 is greater than bond length of O2 2 plus. So O2 2 plus O2 2 plus bond order is O2 2 plus is to cancel out O2 2 minus contain O2 2 plus contain 14 electrons. O2 contains 16 electrons. O2 2 plus contain 14 electrons. So it is similar to nitrogen. Nitrogen bond order is 3. So remember one thing, students. So isoelectronic species have identical bond order. So instead of doing writing these electronic configurations, you compare with other elements. For example, O2 2 minus contain 18 electrons. Isoelectronic species is F2. Bond order is 1. Like that, you can also find out the bond order by indirectly by using this point. Isoelectronic species are identical bond order. So here O2 2 plus bond order is 3 because O2 2 plus is isoelectronic with nitrogen. So O2 so bond order 3. This O2 is bond length of O2 correct. Bond length of O2 is greater than bond length of O2 2 plus because O2 bond order is 2. O2 2 plus bond order is 3. Then final remaining option is option D, bond order of O2 plus and O2 2 minus. Bond order of O2, this is the incorrect option. Bond order of O2 2 minus is 1. Then bond order of O2 plus is 1.5. O2 2 plus means 2.5 bond order. Let us calculate bond order of O2 plus first. So O2 plus contain totally 15 electrons. O2 2 plus is 14 electrons. O2 2 plus O2 plus is 15 electrons. Distribute the 15 electrons. 2, 4, 6, 8, 10, 11, 12, 13, 14, 15. Here bond order is equal to half into 10 minus 5. So the bond order is 2.5. The bond order of O2 plus is 2.5. So bond order of O2 plus, is less than bond order of O2 2 minus. O2 2 minus bond order is 1. Therefore, this option is incorrect. Correct answer is D. Statement is incorrect, but answer is correct. Bond order of O2 plus is 2.5. Bond order of O2 2 minus is 1. The actual statement is like this. Bond order of O2 plus is greater than bond order of O2 2 minus. Okay. The correct option for the question number 17 is D. Next, let us go to the next question. Question number 18. Question number 18. So, you pack name of the compound. So, here write the first. Let us write the complete structural formula. This is the complete structural formula of the given compound. The IUPAC name of the compound. This is the straight chain. So 1, 2, 3, 4. So but at carbon atom number 2, double bond is there. That is but2 parent compound. Substituent is attached at 2 and 3. The compound name is 2,3 dimethyl but2. Option is 2,3 dimethyl but2. Option C is correct. Next question. Question number 19. Among the following, the 5 compounds are given. That is the set which represents aromatic species. Among the following, the set which represent the aromatic species. Here, aromatic species, the aromatic compound means should contain aromatic compound must be planar and it is a cyclic in nature, cyclic compound, and also follow 4n plus 2 pi rule. This is also called Huckel rule. So aromatic compound follow all the 3 conditions. First, let us check one. So first one is benzene. So already there are no. So first aromatic compound is benzene. So this is an aromatic compound. So let us apply the rule. So benzene is planar, cyclic in nature. So after applying the 4n plus 2 rule, it contains 6 pi electrons. So benzene is aromatic. So we are n 4n plus n is number of rings. So 4 into 1 plus 2. 5, that is equal to 6 pi electrons. So option the structure 1 is aromatic. Structure, let us check structure 2. Structure 2 compound is naphthalene. So here this also cyclic in nature and a planar molecule. To apply 4n plus 2, obey 4n plus rule. So 4 into 2 plus 2. So pi electrons contain 10 pi electrons. Here also 10 pi electrons. 2, 4, 6, 8, 10. So therefore, compound 2, naphthalene is also aromatic. Compound 3 is given. That is compound 3, cyclic structure planar, but do not obey 4n plus rule. It contain only 4 pi electrons. 2, 4. So according to Huckel rule, so cyclic contain 1 ring, contain 6 pi electrons, 10 pi electrons like this. So do not obey 4n plus rule, structure 3. Then structure 4 is cyclopentadienyl anion. Here there is due to the presence of lone pair is a cyclic compound to planar molecule and also obey 4n plus rule. Here because of the presence of it contains 6 pi electrons. So 6 pi electrons means 2 double bonded, 2 pi bond, 2 pi here, 4 electrons and 2 lone pair of electrons. So lone pair electrons, so make this molecule, they make this structure as aromatic. Therefore, structure 4 is also aromatic. Structure 5 is not an aromatic because here 4n plus you only contain 8 pi electrons. Single ring, see single ring means 6 pi electrons do not follow 4n plus rule. Therefore, option C is correct. Structure 1, structure 2 and structure 1, 2 and 4. Option B. Correct option is B. Structure 1, structure 2 and structure 4 are aromatic species, represent aromatic species. So next, let us go to the next question. Which one of the following gas converts hemoglobin into carboxyhemoglobin? So hemoglobin reacts with the carbon monoxide to form carboxyhemoglobin. So direct question, this one also. Option C is correct. The carbon monoxide. So hemoglobin combines with carbon monoxide to form carboxyhemoglobin. So it is a highly stable compound. Okay, decreases the carbon carrying capacity of the hemoglobin, the oxygen carrying capacity of the hemoglobin. So because of so carbon monoxide combines with hemoglobin to form carboxyhemoglobin compound. So option C is correct. Next, let us go to the question number 21. What is the oxidation number of sulfur in H2 S2O8? The structure of H2 S2O8 is like this: peroxo disulfuric acid. The name of the compound is the actual structure of compound. Here, oxidation number, oxidation state of sulfur is always -2. So to calculate what is the oxidation number of sulfur, we want to calculate oxidation number of sulfur. So oxidation number of hydrogen is always +1, but oxidation number of oxygen is always -2, except in peroxides. Peroxide it is -1. Here in this structure, two oxygen atoms are involved in peroxide linkages. Peroxide linkages. So in these two compounds, these two oxygen, the oxidation state is -1. So to calculate oxidation number of sulfur is, let us assume oxidation state of number of sulfur is 2. So there are two sulfur atom, 2x plus, here two hydrogen atoms are there. 2 into oxidation state of hydrogen atom always is +1, then plus 6 remaining 6 oxygen atom, oxidation state is -2. 6 into -2 plus 2 oxygen atoms are involved in peroxide linkages. Their oxidation number is -1. So the sum of the oxidation number of all the atoms in a molecule is equal to 0. So let us say x is equal to +6. The value of x is +6. X is the oxidation state of the oxidation number of sulfur. So option B is correct. So in this compound, first let us you should write the structure of the compound, given compound, then calculate the oxidation state, oxidation number of sulfur. Next question is question number 22. The swelling in feet and ankles of an aged person due to sitting continuously for long hours during travel is reduced by soaking the feet in warm salt water. This is because here swelling in feet and ankles of aged person due to sitting continuously for long hours. It means accumulation of solvent or water molecules in the cells, intercellular spaces. Because of this, swelling takes place in the feet and ankles. To reduce the swelling, soaking with warm water. So warm water means a concentrated solution. So by soaking the warm water, so water drawn out from the intercellular spaces and cells from ankles and feet. So reduce the swelling. It means the flow of water molecules from low concentrated solution to high concentrated solution. So salt water surrounding the feet, so contain a more concentrated solution. So solvent molecules flow from low concentrated to high concentrated solution. The process of the phenomenon is called osmosis. Here, edema is the correct answer is osmosis. Edema is a medical condition. The people who take salt and salty food, there is a causes swelling or puffiness in the tissues. Diffusion is the process of movement of the solvent molecules from high concentration solution to low concentrated solution. Reverse osmosis. So the correct answer is osmosis. Okay. The question number 22, the correct answer is osmosis. Next, question number 23. Here, solution, the problems coming from the chapter solution chapter. The sample of water is found to contain 5.85% AB. The molecular mass is given, and 9.5% XY2. Their molecular mass is 95. Assuming 80% of ionization of AB and 60% ionization of XY2, the freezing point of water sample is. Here, what is given in this numerical is number of the mass of solutes are given. Two solutes are mixed with water. Here, you want to calculate the freezing point of the solution after adding the two solutes. 5.85 gram of 85% AB solute and 9.5% of XY2 solute. To solve this, so you have to calculate the delta TF value, depression of freezing point value. Want to calculate formula delta TF is equal to KF into molarity. Here, the solutes are non-electrolyte, so undergo dissociation, undergo ionization. Therefore, I have to include for this formula want of factor value also. To calculate the depression of freezing point, this is the correct formula for this numerical. That is delta TF is equal to KF into want of factor of solute AB into molality of solute AB. After that, then plus want of factor of solute XY2 and molality of solute XY2. So here only Kf value is given, that is 1.86 Kelvin kg per mole. So want to calculate molality of AB, molality of XY2, and also calculate want of factor for AB and XY2. So let us calculate one by one as a lengthy numerical. So here first let us assume so mass of the solution is 100 gram. Mass of the solution is 100 gram. So mass of AB is given. Mass of AB is 5.85%. Straight away write it as 5.85 gram. So molar mass of AB is given. Molar mass of AB is 58.5 gram. 58.5. Therefore, number of moles of AB is equal to 5.85 divided by 58.5. That is equal to 0.1 mole. So, number of moles of AB is 0.1 mole. Similarly, calculate number of moles of XY2. Mass of xy2 is given, that is 9.5 gram. And molar mass of xy2 is equal to 95. So number of moles of xy2 is equal to 9.5 divided by 95. That is also equal to 0.1 mole. Now let us calculate the molality of the solution. So molality of AB is equal to number of moles of AB divided by mass of the solvent, in kg, mass of the solvent in kg. So here number of moles of AB is 0.1 mole, mass of the solvent in kg. So here mass of the solution is 100 gram. To this, mass of the solution contain 5.85 gram of 85 gram of AB solute and 9.5 gram of xy2 solvent. So the mass of the solvent is equal to 100 minus 5.85 minus 9.5. The mass of the solvent is 84.65 gram. So here mass of the solvent in kg is 0.08465 kg. The answer is the molality of the AB is 1.1813 mole per kg. Similarly, calculate the molality of xy2. So molality of xy2 is number of moles of xy2 is 0.1 mole. So mass of the solvent is same 0.08465. So number of moles of molality of the xy2 also 1.1813 mole per kg. So next find out the Vanta factor of I. So I of Vanta for dissociation of solute particles in solution, I is equal to 1 plus n minus 1 into alpha. Here n is the number of ions produced after dissociation, alpha is the degree of dissociation. So degree of dissociation is given, that is 80% of AB and 60% ionization of xy2. 80% means 0.8 degree of ionization of AB is 0.8. Alpha is for AB. Okay, first let us calculate the Vanta factor of AB solute, that is 1 plus after dissociation. Here one condition is given, that is in the question, last sentence. A, B and Y are monovalent ions. So after dissociation, AB gives two ions, A and B. That is Ne value is equal to 2 minus 1 into 0.8. So Vanta factor AB is equal to 1.8. Then Vanta factor of xy2 is equal to 1 plus. So after ionization, xy2 gives 3 ions. Therefore, N value is 3. 3 minus 1 into degree of dissociation is 0.6. This is 60%. A solute undergo ionization. Therefore, Vanta factor of xy2 value is 2.2. So now let us calculate delta TF. Delta TF is equal to Kf into I of AB into molality of AB plus I of xy2 into molality of xy2. Substitute mark. So 1.86 into 1.8 into 1.1813 plus 2.2 into 1.1813. So delta TF is 8.75 Kelvin. So once you find the delta TF value, calculate the freezing point of this solution. So delta, we know that delta TF is equal to freezing point of the pure solvent minus freezing point of the solution. So delta TF is calculated. Calculate delta TF. TF value is delta TF. Uh, uh, so here freezing point of the solution is equal to T naught F minus delta TF. So T naught F is given, that is 273 Kelvin. Delta TF value is calculated, that is 8.75 Kelvin. So freezing point of the solution is 264.25 Kelvin. The answer is 264.25 Kelvin. Correct option is C. Correct answer is C. So now let us move on to the next question. Question number 24. Dimerization of solute molecules in low dielectric constant solvent is due to. Dimerization is due to, because here, for example, dimerization of acetic acid. So you add two molecules of acetic acid in low dielectric constant solvent. So undergo dimerization to form one molecule, one particle of to form one particle. So be due to the dimerization. So dimerization actually the type of bond between the two molecules of acetic acid combined to form one particle. So undergo dimerization. Here acetic acid, second acetic acid, then another molecules of acetic acid combined with this acetic acid molecule with this bond H. H. One second. So undergo dimerization. This is H hydrogen. This is H O C double bond O. This is H. This is CH. So this is one molecule of acetic acid. This is another molecule of acetic acid. These two are linked through hydrogen bond. So what do you mean by hydrogen bond? The attraction force between the hydrogen atom and highly electronegative atom like oxygen. So the correct option is hydrogen bond. Dimerization of solute molecules in low dielectric constant solvent is due to hydrogen bond. So next question. So here the next question, question number 25 is for a reaction, the value of rate constant at 300 Kelvin is 6.0 into 10 to the power 5 per second. The value of Arrhenius factor A at infinitely high temperature is. So Arrhenius equation is K is equal to A into e to the power minus EA by RT. Here, the question is when the temperature increases, Arrhenius factor rate constant K also increases. Here, at infinitely high temperature, this value e to the power minus EA by RT value approaches to 1 or is equal to 1. Because when the temperature is infinite, the term EA by RT becomes 0. So the term e to the power minus EA by RT is equal to 1. So therefore, at infinitely high temperature, K is equal to A. So the correct answer is B. So for a reaction, the value of rate constant at 300 Kelvin is 6.0 into 10 to the power 5 per second. The value of Arrhenius factor A at infinitely high temperature is same, remains same, 6.6 into 10 to the power 5 only. So correct option is B. Next, question number 26. Yeah. The rate constant K1 and K2 for two different reactions are 10 to the power of 16 into e to the power minus 2000 by t and 10 to the power of 15 into e to the power minus 1000 by t respectively, when the temperature at which K1 is equal to K2. Okay. So K1 value is given, that is 10 to the power 16, 10 to the e to the power minus 2000 by t. Then to the K2 value is also given, that is 10 to the power 15 into e to the power minus 1000 by t. So the temperature at which K1 and K2 is equal to. So we can write it as when K1 is equal to K2, K1 is equal to K2. The K1 value is 10 to the power 16 into e to the power minus 2000 divided by t. K2 value 10 to the power 15 into e to the power minus 1000 by t. Okay. Then it can be, so here 10 to the power of 16, 15 cancel. So 10 is equal to, it can be written as e to the power 1000 plus 1000, e to the power e to the power 1000 divided by t, because here e to the power minus 1000 by t can be then e to the power of minus 2000 by t. The answer is e to the power 1000 by t. Then put logarithm on both sides. Ln 10 is equal to ln e power 1000 by t. Then ln 10 is equal to 1000 divided by t to ln e. So ln e base e is equal to 1. So ln natural log converted into log them base 10, 2.303 log 10 is equal to 1000 by t. Then t, we know that log 10 value is 1. Therefore, t is equal to 1000 divided by 2.303. So the correct option is A, 1000 divided by 2.303 Kelvin. Next question number. During electrolysis of brine by using inert electrodes. Option A is a sodium deposit on cathode, chlorine liberates at anode, oxygen liberates at anode, hydrogen liberates at anode. So let us check which one is the correct answer. Here, brine solution means nothing but aqueous sodium chloride solution. So sodium chloride solution is called brine solution, sodium chloride solution. So in aqueous solution, contain four type of aqueous solution of brine solution contain four types of ions: Na plus, Cl minus, aqueous, along with water also dissociate to give H plus aqueous and OH minus aqueous ion. OH minus ion. So contain H plus ion, OH minus. Here during electrolysis, so here cations are moved towards cathode. So both sodium and sodium ion and H plus ion move towards cathode, and anions are moved towards anode. So in that cathode undergo reduction, anode undergo oxidation. So here at cathode, the question at cathode for reduction there is a competition between two ions, Na plus ion and H plus ion. So at anode reaction, so having the reaction with higher value of E naught is prepared. See the Na plus undergo reduction to form Na. So H plus ion takes electrons, becomes half H2. So here E naught value of Na sodium reaction minus 2.71 volt. Here E naught value of hydrogen is 0.0 volt. So at cathode, the reaction with higher value of E naught is prepared. Reaction with higher value of E naught is prepared. Here hydrogen undergo reduction to form hydrogen gas. So higher value of E naught is 0.0 for this one. So the hydrogen liberates at cathode. So in this option, it is not given. Hydrogen at anode is given. That is not the correct answer. So at cathode, anode is given. Chlorine liberates at anode. Oxygen liberates at anode. Sodium deposits on cathode. So sodium ion not deposited. So option A is also not correct. Now let us take the anions. Chloride ion and OH minus ion move towards anode. Here at the anode with at anode reaction with lower value of E naught is prepared. So here lower value of E naught is, so for oxygen actual value is lower value for oxygen. There is Cl minus L2 plus electron. So E naught value is equal to 1.36 volt. In anode, water undergo oxidized to oxygen plus 4H plus 4 electron. So that is E naught value is 1.23 volts. At anode, reaction with lower value of E naught is prepared due to over potential. So chlorine gas is liberated at anode. This is the main reason. So actual answer is B. So chlorine liberates at anode. So chlorine liberates at anode. So actual lower electrode potential value is for oxygen 1.23, but due to over potential of oxygen, chlorine is liberated at anode. So option B is correct. Next, question number 28. Question number 28. Consider the following four electrodes. Consider the following four electrodes. Four electrodes are given. That is A, B, C, and D. Concentrations also given. So the reduction potentials in volts of the electrodes in the order is. Then the reduction potentials in volts of the electrodes in the order is. Actually, silver undergo reduction to form silver metal, silver ion. Here, of the Nernst equation for option is Ag plus Ag, that is equal to E naught Ag plus Ag minus 0.059 divided by N log of 1 by molar concentration of silver ion. And this equation can be written as E naught of Ag plus Ag plus 0.059 divided by N. So reverse of this one, log of Ag plus. So this shows that molar concentration of silver ion increases, electrode potential of reduction potential of Ag plus Ag also increases. So let us check the order. Here I concentration is electrode B 0.1 molar concentration. That is B reduction potential is higher. So option C, B reduction potential is higher. Then Next concentration is C, 0.01 molar concentration, C. Next is D, 0.001 concentration. So final one is A, so lower concentration. So lower reduction potential value for A, for electrode A. The correct option is B. So this is how it increase the concentration of the silver ion, the reduction potential also increases. So question number 28, option C is correct. Next, let us check. Let us go to the question number 29. The resistance of 0.1 molar weak acid HA in a conductivity cell is 2 into 10 to the power 3 ohm. 3 ohm. The cell constant of the cell is given, that is 0.78 per centimeter. So limiting molar conductivity of acid is also given, that is 390 Simon centimeter square per mole. The pH of the solution is. See here, what happens is the first you have to calculate pH of the solution. pH formula, pH is equal to negative logarithm to the molar concentration of H plus ion. See here, weak acid is given. First calculate the H plus ion concentration. Here, first resistance is given, cell constant to conductivity, cell constant is given, cell constant is given. So let us find the conductivity. So conductivity kappa is equal to 1 by rho. Resistivity, rho is called resistivity. So this can be written as resistivity related with resistance. R is equal to rho L by A. Then rho is equal to R into A by L. Here L by A is called cell constant. Substitute the value of rho in this equation. So then K is equal to 1 by R into L by A. So then it can be written as K is equal to G into R. G is called cell constant, that is given, that is 0.78 per centimeter. Then resistance value is also given, that is 2 into 10 to the power 3 ohm. Answer is 3.9 into 10 to the power minus 4 Simon per centimeter. Next, calculate the molar conductivity. So molar conductivity is equal to K into 1000 divided by C. Concentration of the solution is also given. Conductivity is now calculated. 3.9 into 10 to the power minus 4 divided by into 1000 divided by 0.1 mole per cm cube. The answer is 3.9 Simon centimeter square per mole. So once you find the molar conductivity of the weak acid, find out the dissociation, degree of dissociation. Alpha is equal to lambda m by lambda naught m. So then lambda m calculated just now, 3.9 Simon centimeter square per mole. And then lambda naught is given, limiting molar conductivity, that is 390 Simon centimeter square per mole. So the answer is 0.01. So degree of dissociation is, so for weak acid, HA gives H plus ion, A minus ion. So initially C minus C, initial concentration before undergo dissociation. So concentration of H plus and A minus is 0. And after C alpha particles, C alpha molecules of HA dissociate to give C alpha H plus and C alpha A minus n. Therefore, the concentration of H plus ion is C alpha. Then, so H plus ion concentration is given, that is 0.1. Alpha just now calculated, just 0.01. So the molar concentration of H plus ion is 0.001. That is equal to 10 to the power 3 minus 3. And pH final, pH is equal to negative logarithm of 10 power minus 3, that is equal to pH value is equal to 3. So the correct answer is B. Next question is, in which one of the following reactions the rate constant as the unit of mole per liter per second? So actually this is the unit of zero order reaction. So which one is zero order reaction? Is here option A is three molecules are involved in three third order reactions. So we are decomposition of hydrogen iodide on surface of the gold. Any reaction, all surface reactions are zero order reactions. Therefore, correct option is B only. So here acid catalysis of hydrolysis is a pseudo first order reactions. Then CH3Cl, CHCl3 and Cl2 is a second order reactions. So zero order reaction is decomposition of hydrogen iodide on surface of gold. All surface reactions, catalytic reaction, all surface reactions are zero order reaction. Therefore, correct option is B. Next, question number 31. The reducing agent in the given equations. So four options are given. So there are two equations are given. Here, oxidation number of Ag is 0, changes to +1. Therefore, in the first equation, silver undergo oxidation. So therefore, it acts as a reducing agent. Okay, let us check all the elements. The oxidation number of oxygen in O2 is 0. It is O2 is 0. In OH minus is -2. Oxidation number of carbon and nitrogen remains same in both reactant and product side, do not change. Oxidation number of carbon and nitrogen do not change in these reactions. Therefore, in the first equation, silver is the reducing agent because silver oxidation number changes from 0 to +1 itself undergo oxidation. Therefore, it is the reducing agent in the first reaction. Let us check second one. In the second reaction, silver oxidation number is reactant side is +1, product side is 0. Oxidation number decreases from +1 to 0. Therefore, in the second reaction, silver undergo reduction. Silver undergo reduction. Here it acts as a oxidizing agent. Zinc oxidation number is 0 to +2. So zinc undergo oxidation. In the second equation, carbon and nitrogen oxidation number remains same in the second equation also. Therefore, here in the second equation, zinc is the reducing agent because it undergo oxidation. So oxidation number increases from 0 to +2. So overall, in both the overall equations, zinc is the reducing agent. Because silver is not the reducing agent, because in first equation it acts as a reducing agent. In the second equation, it is acts as an oxidizing agent. Therefore, final reducing agent is zinc. Option C is correct. Next question is, which of the following is correct with respect to melting point of transition element? So here, with respect to melting point of transition element, here so 3D series elements are given. So here scandium, titanium, vanadium, chromium, manganese, up to manganese is given. Generally manganese. Here with increase in atomic number in a 3D series, atomic number increases, number of unpaired electrons also increases. So here melting point, it depends upon the bond strength of the metallic bond, strength of the metallic bond. So here n-1 d electrons are involved in metallic bond. So more number of electrons. So in the, generally in the 3D series, 4D series, and 5D series, starting up to the middle melting point, strength of the metallic bond increases, then middle decreases and start increasing almost same at the end. Melting point, metallic bond strength both. So here the correct option is manganese melting point is greater than iron. That is not correct. Manganese melting point is less than iron. So titanium melting point is greater than vanadium. That is not correct. So so titanium melting point is less than vanadium. So vanadium melting point is greater than chromium. Then chromium melting point is greater than is greater than manganese. Which of the following is correct with respect to melting point of transition element is given here. Okay, so here melting, which of the following is correct? So vanadium melting point. Okay, chromium melting point is greater than manganese because in the 3D series, chromium melting point in high means manganese melting point is suddenly drops. So because of their electronic configuration. So number of electrons, stable electronic configuration of manganese. Okay. Then less number of unpaired electrons are involved in metallic bonding. So option D is correct. Next, let us go to question number 33. In 33 questions, what is the balanced equation is given and both reduction and oxidation take place. So stoichiometric coefficients of A and Y want to calculate. Here, uh, so manganate ion, manganate ion, MnO4 minus ion, generally is a very good oxidizing agent, reduced to MnO2. Reduced to MnO2. Here, MnO2. So to balance the oxygen atom, here oxygen the manganese atom in both the side is balanced. The oxygen atom in this side, actually this reaction takes place in alkaline medium. In alkaline medium, to balance the oxygen atom, so to add the water molecule within the side of the excess of oxygen itself. See here oxygen atom, two oxygen atom more in the reactant side compared to product side. Therefore, add two water molecules, MnO4 minus plus 2H2O in the reactant excess side itself, then MnO2. So to balance the hydrogen atom, opposite side add same number of hydroxyl ions, OH minus. So now let us check the charge. In reactants, the product side 4 negative charges there. The product reactant side 1 negative charges. To balance the charges, add reactant side 3 electrons. This is equation number 1. Next, thiosulfate S2O32 minus is oxidized to sulfate ion SO4 2 minus. Here number of sulfate ion both the side is here add 2 sulfate ion. Then number of oxygen atoms. So in reactant side, number of oxygen atom reactant side 3 oxygen atom. Product side 8 oxygen atom. There is a 5 oxygen atoms are deficient. Here so add product side 5 water molecules. Actually, 5 oxygen atoms less in reactant side. The excess side itself add water molecules, that number of water molecules to balance the hydrogen. So opposite side, that number of OH minus ions, that is 10 OH minus ion. So now balance the charges. In reactant side, totally 10 minus plus 2 minus 12 charge. Product side only 2 into 2, 4 minus charges there. So add 8 minus 8 electrons to in the product side. This is equation number 2. In both the equations, redox reactions, now in redox reactions, Number of electrons lost is equal to number of electrons gained. To balance the, to equalize the number of electrons lost is equal to number of electrons gained. Equation number 1 is multiplied by 8. Equation number 2 is multiplied by 3. So final expression, final equation 8 multiplied by, that is 8 MnO4 minus plus 3 S2O3 2 minus. Then water molecules, this side 8, 16 water molecules, this side 15 water molecules, one excess water molecules reactant side, add water. Then 8 MnO2 plus 6 SO4 2 minus plus OH 32 OH minus an product side, 30 OH minus an reactant side. So the product at 2 OH minus an excess. Therefore, A and this is A and Y in the reaction is A is 8, Y is 6. Correct option is D. Stoichiometric coefficient of MnO4 minus is 8. Coefficient of sulfate ion is 6. Now let us go to the question number 34. Which formula and name combination is incorrect? So here let us check first one. That is dichlorido, correct? Dichlorido. Then En twice ethylene diamine. So here ligand itself contains prefix like di. Therefore, here we do not use, don't want to use the di again 2 times. Therefore, instead of using di, you have to use bis. And also, this name is incorrect. And also the cobalt is actually, the name is dichlorido bis, within the bracket ethylene diamine cobalt. This oxidation number of cobalt is also given wrong. That is oxidation number of cobalt is 3. So chloride. So the correct name is dichlorido bis ethylene diamine cobalt 3 chloride. So option A itself is incorrect. So the remaining 3 options are correct options. Correct name. Next, which of the following system in an octahedral complex has maximum unpaired electrons? Here octahedral complex is given, and in the option is given option, it is given low spin, high spin, high spin, low spin, high spin, low spin. Here, so we have to apply crystal field theory to solve these questions. So according to crystal field theory, 5d orbital split into 2 sets, that is T2G set and EG set. This is EG set, this is T2G set. Here, the difference in energy between the EG and T2G set is called delta naught, crystal field splitting energy. Okay. So, want to fill the electrons. If delta naught is less than P, the P means pairing energy. The electrons fill in the EG orbitals before pairing the T2G orbitals. If delta naught is greater than P, crystal field stabilization energy is greater than pairing energy. Electron pair in electron pair in T2G orbital before going to fill in the EG orbitals. So let us apply one by one. So option A is given, that is in option A D4. D4 here also within the bracket is given, that is low spin. So if delta naught is less than P, electrons fill in EG orbital before the P to G orbital to form low high spin complexes. Okay, strong field ligands, high spin complexes. So delta ligands are known as weak field ligands and form high spin complexes. If delta naught is greater than P, ligands are known as strong field ligands and also form low spin complexes. So your low spin complex D4 is low spin complex. Low spin complex means what? Delta naught is greater than P, low spin complex. So so distribute the electrons. So 1, 2, 3, 4. So in low spin complex contain only two unpaired electrons. This is contain two unpaired electrons. D7 configuration. D7 high spin complex. High spin complex means delta naught is less than P pairing energy. So 1, 2, 3, 4, 5, 6, 7. So there are three unpaired electrons in D7 configuration. D9, so whether it is low spin or high spin, always has only one unpaired electrons. D6 configuration, that is low spin 1, 2, 3, 4, 5, 6. So no unpaired electrons in D6 configuration. No unpaired electrons. Therefore, correct option is P. So D7 contain three unpaired electrons. This is D7 high spin complex. High spin complex contain more number of unpaired electrons. Therefore, for question number 35, option is B. Next, question number, in which one of the following pairs both the elements does not have n-1 D10 and ns2 configuration? In which of the following pairs both the elements does not have n-d10 ns2 configuration? Here zinc is given, then cadmium is given, then mercury is given, then Cn is also given, copernicium, and also along with copper is given. Here, these zinc, cadmium, mercury, and copernicium are group 12 elements. Group 12 elements. The electronic configuration is n-1 D10 ns2 configuration, completely filled cell. So therefore, in which of the, for copper electronic configuration is 3D 9 3D10 4s2, but zinc configuration is 3D10 4s2. Copper is 4s1. 3D copper electronic configuration is 3D10 4s1. So copper do not have n-1 D10 ns2 configuration. Therefore, copper zinc combination is correct. Correct option is B. So mercury and copernicium contain same configuration, n-1 D10 and ns2 configuration. Now, zinc and cadmium and mercury, and all the three options. So contain n-1 D10 and ns2 configurations. So correct option is B, because copper electronic configuration is 3D10 4s1 configuration. Next, question number 37. Hybrid, so your reaction is given. Hybridization changes involved in at C1 in the above reaction. So here the first one is given, that is a primary alpha. Next gives oxidized to aldehyde. Already discussed in previous questions about the suitable oxidizing agent for primary alcohol to aldehyde. So PCC, pyridinium chlorochromate. So here, primary alcohol, the structure is like this. So carbon contains single bond only, that is sp3 hybridization. In aldehyde, carbon contain double bond. Okay, this is sp2 hybridized carbon atom. So therefore, hybridization change involved at carbon atom number 1 in the above equation. Here carbon atom number 1 means carbon atom containing the functional groups. Directly attached to the functional groups are known as carbon atom number 1. Okay. So here oxidation, hybridization change involved at carbon atom number 1 in the above equation is hybridization changes from sp3 to sp2 hybridization. So the correct option is D. sp3 to sp2 hybridization. Next, which of the following is an organometallic compound? So organometallic compound, general formula of organometallic compound is RMgX. Here organometallic compound is option D, organometallic compound. So next question is question number 39. A pair of compound having the same boiling points. So benzene and naphthalene, different compounds, and different do not have same boiling point. Here plus butane 2-ol and minus butane 2-ol. These two are optical isomers. Optical isomers means compounds having the same molecular formula, same structural formula, same physical properties, but differ in the rotation of plane polarized light. Therefore, so compound butane 2-ol and plus dextrorotatory and levorotatory butane 2-ol are having the same boiling point. So correct option is B. Question number 40. Identify the next question is question number 40. Identify A, B, and C in the sequence. Here, alkyl halide is given, that is CH3, CH2, Br. So that is treated with potassium cyanide, alcoholic potassium cyanide. So what happens here is alkyls undergo nucleophilic substitution reactions. So bromine atom, bromine replaced by cyanide. The product is CH3, CH2, Cn. So the compound name is propane nitrile. Name is propane nitrile. Here, first is second. That propane nitrile is formed. So here for first compound is CH3, CH2, Cn. So it is given in the which option? See, option A is given CH3, CH2, Cn. Option B is also given. Option C is also given. So option D is not given. So option D is not correct. Then CH3, CH2, Cn is treated with the lithium aluminum hydride. So reducing agent. So very good. Reducing agent undergo reduction. So here propane nitrile undergo reduction in presence of reducing agent lithium aluminum hydride gives amine CH3, CH2, CH2, NH2. Propyl amine is formed. It is propyl amine. So here C triple bond N undergo reduction. CH to CH2 reduction 4H. So second compound is CH3 CH2 CH2 NH2. CH3 CH2 option A, it is not there. Option B, CH3 CH2 NH2 is given. It is also not correct. Option C is given. That is CH3 CH2 CH2 NH2. So this is the correct answer. Let us check the another reaction. Next, CH3 CH2 CH2 NH2. It is treated with amine is treated with HNO2 at 0 degrees Celsius, low conditions. So what happens here is first it gives the diazonium salt. Diazotization reaction, that is CH3 CH2 CH2 N2Cl. This compound is unstable, therefore undergo hydrolysis, form alcohol CH3 CH2 OH. So that is option C, because aliphatic diazonium salts are unstable compound hydrolyzed to form alcohol. So with this, thank you. With this, I'm going to end my session. So thanks for the opportunity given by our Seshadripuram Education Institute of Technology and Seshadripuram Education and Trust. So tomorrow I will put. So tomorrow we're going to have another session, paper 2. So I have taken by Chaitra madam. Thank you.